Hello, good morning, good afternoon, good evening, depending on when you are seeing this video. Welcome to GIT. In this course, we are going to learn text analysis using NLP. So, by way of introduction, my name is Okunama George. I am a data scientist, also a machine learning engineer with over 2 years of experience. All right. So, in this tutorial, in this course, we are going to learn how to use text and do analysis in our computer. Now, without further ado, let's go dive into our course outline for today. So, the first thing we are going to look at today is that our course tutorial analysis table of content rather is that 1, we are going to look at what is NLP. 2, we are going to look at installation. 3, tokenization, lemmatization, part of speech tagging, named entity recognition, and dependency parser. So what is NLP? NLP stands for natural language processing. It's a field of artificial intelligence that focuses on the interaction between computers and human languages. Now, it's a field of artificial intelligence, and we can use text to do what? To build a model in machine learning that will make prediction for us. So NLP is a natural language processing that helps computers to interact with human languages. So it enables machines to understand, interpret, generate, and manipulate natural languages in meaningful way. So NLP combines linguistics, computer science, and machine learning to perform tasks such as what? 1, text analysis. So for us to have a better model using text, we need NLP. NLP has to come in place. We need to do text analysis using NLP. Alright, so we can do text analysis to understand the sentiment analysis, topic modeling, speech recognition. Now, there is one gadget that was created by Google known as Series. Okay, so it is that NLP is the backbone of any speech recognition software or visual assistance. All these are translating text from language to language. So NLP is a very powerful field of study. It's a very powerful field of artificial intelligence that it is used in almost every area of our endeavor. So if you are undergoing this course, if you have taken this course, so it means you are in the right place. So I will try my best to ensure that I teach you from scratch to finish all about NLP, and we are going to use a library known as what? spaCy. So spaCy is a NLP library. It's a Python library used for text analysis and also sentiment analysis. So without further ado, let's go to how we can install our spaCy. All right, so let's go to the next one, installation. So for you to install spaCy, you need to have Python already installed in your computer. You can dive into your computer, go to Google and type download Python. So the steps are very simple. So for you taking this course, I have assumed you already have your Python installed. So let's dive into my command prompt. Let's go ahead and create a folder, cd desktop. Okay, all right, so let's make a directory known as NLP underscore tutorial. All right, so let's navigate to my NLP underscore tutorial. Okay, all right, so we have been able to create our folder. If we should go back here to our computer, you see we have NLP tutorial. All right, so let's continue. Now what we want to do now is we want to open our VS Code from this but before we open our VS Code, go ahead and type pip install -u spaCy. All right, you click on enter. So it's going to load, and for me, I have already say requirements, specifier, package, index options. Now I have already gotten this. All right. So or you can say pip install spaCy. All right. So now this is because I have already installed spaCy in my computer. It's telling me that requirement already satisfied. All right. So now there's another pipeline. We need to download a pipeline. That pipeline is called Core Web SM. All right. So if you have successfully installed your spaCy library, go ahead and type Python. All right, -m, write spaCy download. All right, you want to download. What are we going to download? We are going to download this en_core_web_sm. Basically, this is an English model. So this spaCy is a pre-trained algorithm for performing text analysis. So we want to download a small model. We can, and we are using EN, stand for English Core Web SM. You can go ahead and look at the spaCy documentation. You see all this right there. So you go ahead and click on enter. All right. So it's going to load and it's going to download for you. But for me, since I have already downloaded and installed spaCy in my computer, this will return as requirement already satisfied. All right. So I will not bore you with time. All right. Look at it, is going. So I'm going to close this. All right. So we are going to now let's navigate to my desktop again. Let me navigate to my NLP _tutorial. All right, so we are done with our first assignment, which is to install spaCy and also to download the Core Web. All right, so the next thing we want to do, we want to look at a concept in spaCy or NLP known as tokenization. So before then, let's go ahead and navigate to, let's say, code. I want to open this in my VS Code. All right. So if you stay here, we are in our NLP tutorial folder we created. So let's go ahead here and just do, let's say, NLP dot. I want to use Jupyter Notebook IPYNB. All right. So basically, what this does is that we're using Jupyter Notebook in our VS Code. You can as well do this in your Jupyter Notebook. So I like using VS Code, is personal preference. You can look at any IDE that is best suitable for you. You can go ahead and use it. So the next thing we are going to do from our course table of content, after we have looked at what is NLP, we have been able to install our package, all right, which is spaCy. We are looking at the next one. We are looking at tokenization. What is tokenization? Before we dive into our practical aspect of it. So tokenization is a process of breaking down a piece of text into smaller units called tokens. Maybe you have a very large text or a document that has different sentences or that have sentences in that document. So what tokenization does is that it breaks it down into smaller units, into piece by piece. And that process of breaking down those texts, a document, into smaller units is called tokenization. And the pieces which it has been able to break it down is called tokens. Now, tokens can be words, phrases, symbols, or even sub-words, depending on the context. So in spaCy, tokenization splits text into meaningful components while preserving linguistic rules such as handling punctuation, contractions, and spatial characters accurately. Now, don't forget that tokenization, what it does is that it breaks down text into smaller units, and it could be words, phrases, or symbols, and they are meaningful. That is the beauty of it, not just breaking something down, they are meaningful. So let's dive into our tutorial to our VS codes. All right, so haven't done that, you have been able to install. You need to see if your what you installed, spaCy, is working. You go ahead and import spaCy. All right, once you come to this play button and you click on this, or if you are using on Windows, you can do shift enter. All right, so I'm going to use shift enter. So since I'm loading for the first time, it's going to load, and let's just be patient. I want to show you everything from scratch. All right, so our spaCy library has been successfully installed. If yours is giving you an error, please do well to refer back to spaCy documentation to see how well you can install your spaCy and download the model. That English Core Web SM is called a pipeline. It's a pre-trained model which we are using to do what? For our text analysis. All right, so the first thing we need to do is to load that our model, that pipeline. How do you do that? You say NLP, all right, equals to spaCy, all right, dot load. What are you loading? You are loading this en underscore core underscore web underscore sm. So you go ahead and do what? And run this. Let's see if we are going to have error. So we do not have error. We've been able to install our spaCy library, and also been able to successfully download our English Core Web small model. All right, so now let's go ahead and look at the example, one of the examples of tokenization, because our emphasis is tokenization right now. Like I said, tokenization is a process of breaking down text into smaller units which make meaningful word sense. All right, let's go ahead and do and say, all right, say text equals, so you can write whatever you want to write here. You can say I love NLP because it is so powerful and trending right now. All right, so if I go ahead and run this, now let's go ahead and print our text. All right, so you see your text. All right, so we've been able to write our first sentence. All right, so I love NLP because it is so powerful and trending right now. Now we are going to convert this text into a token. We are going to break this down into smaller units. So let's go ahead and do that. How do we do that? Now remember, we have a text. First of all, we are going to convert this text into a document. Now there are there's a difference between text and a document. Now I will show you in a second. Let's just go ahead and say doc 1. That is document 1. Let's say NLP, okay, and you put in your text and you run it. If I go ahead and then call doc 1, all right, it's going to give me. Now when you look at this, the first one is the text. I love NLP because it is so powerful and trending right now. Now we convert that text into a document, and you look at the same thing. When you print this document, it's still giving you as I love NLP because it is so powerful and trending right now. If you look at it from the general point of view, you might not see any difference in these two texts. It is only when we go ahead to loop this, to iterate over each of these, you will now see the difference. All right, so if I say print text dot shape, all right, if I go ahead and run this, string, okay, all right, so let's just do print len of text. All right, so if we print the length of text, is giving us as what? As 60. All right, please, I want you to take note. I want you to take note and ensure you follow this course very well. All right, now if we print the text, the length of this text here we having, you know, if you look at the text and the document, one is the same right up. Now the length, what differentiates the text and the document is the length of each of them. Now I printed the length of text is giving us as 60. Let's go ahead and also print the length of document 1. That is document 1, and let's go ahead and run it. Now if you look at here, you know, this is where most programmers or most data scientists or NLP engineers fail to understand. Now when you come to this text, it's giving us as a length of 60, but when you come to printing of this length of the document 1, it's giving us the length of 30. Now what is going on? Now let me explain. Please, I want you to pay very close attention to this. It might be tricky. All right, so once you get it, you get it well. Right, now the text is giving us, if you look at the text, you want to count it by numbers. Okay, the text count each of this alphabet, it counted as 1. It counts individually. If you go ahead and say I1, L2, O3, VE, E5, N, so that is how this text count whatever we have here. But when you come to document does not count based on individual alphabet. Remember, we said tokenization is a process of breaking down text into smaller units, which makes sense. All right, now if you come to document, it gives you based on words, just words. All right, now it say I as 1, love as 2, NLP as 3. So that is why we are having this text more than what we have in our document. Let me go ahead and explain further to your understanding. Please, I want you to understand this course, this tutorial very well, because it is very, very important you understand this concept. Now, if I go and use for loop, we use for loop a lot. Everything I want to do, we are going to be using for loop. So if you do not have a basic background in Python, please, I will encourage you, pause this video or stop this video for now. Go ahead, go back and learn Python fundamentals. So we want to say for, let's say token in text. All right, I want you to print what? Token. Now what I'm doing here, I say for token in text, which is this, print this text. Now if I go ahead and run this, oh wow, like I said, it counts individually. All right, so it's counting alphabetically, one by one. So for text, it's giving us I-L-O-V-E. That is why we have it as a length as 60. All right, so if we go ahead and change this to document 1, and we go ahead and print our document, all right, you see now it has been able to reduce. Now in document or token, what token does is that it splits sentences or text into meaningful words, into smaller units. Now initially we're having I-L-O-V-E individually, but in document it's giving us as based on word. I love NLP because it is so powerful and trending right now. So that is the difference between tokens and text. So for tokens, it's been able to do what? To break it down into smaller unit, which makes sense. Not just smaller unit, but smaller unit that does what? That makes sense. So I hope you have understand the difference between text and tokens. All right, so let's go to our course outline and look at the next concept. What are we looking at? We are looking at lemmatization. Okay, sorry, lemmatization. Now what is lemmatization? We say lemmatization is a process of reducing a word to its base or dictionary form known as lemma. Now, unlike stemming, lemmatization considers the context and part of speech of the word to ensure accurate transformation. And for example, we have lemma of running is run. The lemma of better is good. All right. So in spaCy, lemmatization is performed using language-specific rules and lookup tables, which can be accessed through the token.lemma attribute for each token in a text. All right. I want you to understand this course very well, please. That is why I had to make this presentation very well. You can take notes for future references. Now, for lemmatization, we say it reduces words to its base or dictionary form, and that process is known as lemma. And we have example given as running, it reduces to run instead of running. Now better, it reduces to what? To good. And spaCy perform this token by using a simple concept, token dot lemma. All right, so let's go ahead to our VS Code and do this. All right, so we are going to look at, okay, let me go ahead and put here as all right, so let me do a markdown. Okay, this is what we call tokenization. All right, so what we are going to do next is what we call lemmatization. All right, so let's go ahead and do a simple example. All right, so I'm going to use doc2 equals to NLP. All right, let's say better days are ahead of us. So good days will come running to us. All right, so let's go ahead and run this. Now we are going to use a for loop. Like I said, we are going to be working with for loop all through. All right, so it's just a concept in NLP, natural language processing. All right, so we are going to do lemmatization. Like we said, that lemmatization reduces a word or a sentence into its root form. All right, so let's go ahead and practicalize it. Let's say for token in doc2. All right, let's go ahead and print token.text, and again let's go ahead and print token.lemma. You do underscore, please. This is just a concept. You must ensure you put that underscore after lemma. Let's go ahead and print it. Okay, I did not spell this token very well. Please always ensure your spellings are all right. Now, let me do something. All right, after this, let me just put let me put a space here so that we can, let me put a space. All right, so let me just do something. Okay. Alright, so let's run. Alright, basically what I did is that I added a blank space. When you put double quote or single quote, you space it. You're going to give space between this text and this lemma. Okay, and this arrow has to point to the lemma. Alright, so when you look at this text, we had better days are ahead of us, good days will come running to us. Now when you come to, after doing lemmatization, better, the root word for better is well. Now days, it reduces to its normal original root word dictionary word as they. R, it says is be. Ahead is still ahead. Off is off. Us is a we. Now this comma is mean comma. Now good is a good. Days, day again. Will. Come. Now running, it reduces to what? To run. To, us, we. Alright, so basically what lemmatization does is that it reduces every word to its root words. Alright, so or a dictionary word. When you go to dictionary, this is a dictionary word or its root word. Alright, so this is what lemmatization does. It reduces the word into its original or root form. Now when you come to running, now it gives us as what? As run. That is the root word for run. So this is lemmatization. I hope, please, if you have any question, do well to put on the comment section. I will do my best to ensure that I give you answers. Alright, so let's go to our course outline. We are done with lemmatization. Let's go ahead and look at part of speech. Like I said, that in natural language processing, it deals with human language. So for now we are using English language. You can use it to do German, Spanish, French, whatever. The same procedure, the same process. You can use it. You only need to download this model that support that language. What we did is that we only downloaded an English model because I'm working with English language. So if you are working with any other language, you can as well go ahead and download it as pertaining to your area or your choice of language. Alright, so let's look at part of speech and tagging. It's a part of speech, POS. Not this confidential POS or point of sale or POS, that is part of speech. Tagging is a process of assigning a grammatical category such as noun, verb, adjective, pronoun, etc. to each word in a text based on its context. Now, POS tagging helps in understanding the structure and meaning of sentences. Now, like I said, alright, so what we are going to do now is that we are going to look at the part of speech. Now, in every grammar, now what part of speech does is that it assigns a grammatical category such as a noun, verb, adjective, pronoun to every word that we have. Excuse me for that. So we are going ahead to go to our VS Code and look at how we can perform this simple operation. Please, you can go ahead and copy all this. That's what I had to give you as a PPS format that you can also take note or take screenshot for reference purposes so that you can understand this. In case you have a job as an NLP engineer or analyst or analysis, you can as well pass your interview based on this course. Alright, so without wasting much of our time, let's go to our VS Code. Alright, so we are going to say here, we are going to do part of speech. Alright, now we are going to use the same document. Okay, I wouldn't want to go ahead and be typing, but I'm going to change this to 3. Alright, document 3 and run it. Now let's go ahead and do our for loop to get our part of speech. Like I said, for loop is what we are going to use throughout this course. Say for token in document in doc 3, rather in doc 3. Alright, so you say print. We're going to print the token.text, and let's go ahead and give a space. Okay, and do this. It's just my choice. You can as well do yours. Token.pos, that's part of it. You do underscore. This is why I love VS Code. It auto-populates or auto-complete your sentence for you. If I go ahead and run this, now you see that in our text, all right, the part of speech for better is adjective. The part of speech for days is a noun, because a noun is the name of a person, animal, place, or thing. All right, so days is a noun. Are auxiliary. Ahead is adverb. All right. Noun of is ADP. Us is a pronoun, and this is telling is a punctuation. It understands. Now, NLP is very good, right? And spaCy is the fastest, easiest NLP library or Python library for NLP operations. Now we have other library for NLP jobs or analysis. We call it NLTK. Okay, it's a bit kind of slow, but it's good though. I'm not condemning it. I started using it before I found that spaCy to be very powerful and easy, most especially for beginners like us. All right, so this is what we call part of speech. It's giving us the part of the grammatical value or placing of a particular word. For better, it's an adjective. Now you can build a model. Now in our subsequent video or course I'm going to create how we are going to use what we have learned to implement it to build a machine learning model for each of these. Okay, I already made a video for how to do text summarization. Text summarizer is summarize text. All right, you can have a bunch of text, you summarize to a little quantity. So we can use NLP for that. You can use NLP for visual assistant, but you can also use it with other pre-trained models from Hugging Face and also LLM's sites. All right, but that is not our focus for today. But all we want to do now is how we can use NLP for text and sentiment analysis. All right, so this is how you can use NLP or spaCy library to get your part of speech. Please, if you have any question, do well to put on the comment section. Please, if you are finding value in this video, in this tutorial, in this course, if you're on YouTube, please do well to go ahead and do what and smash that like button. And also, if you have not subscribed, do well to subscribe to this channel. Thank you. All right, so let's go ahead to our course. Now the next thing we are going to look at here is named entity. All right, these are second to last, named entity. Now what is named entity recognition? See that named entity recognition, for short NER, is the process of identifying and categorizing named entities in text such as people, organizations, dates, locations, and more. In spaCy, the NER model assigns entity labels to spans of text, enabling structured data extraction from unstructured text. All right, so basically what this is saying, all this grammar is talking about, is that it gives, for example, you have a text or a document, you want the model to bring out the entities like place, name, the event, or whatever. All right, date. Now is going to do that. That is what we call named entities recognition. Let's go ahead and say here is our named entity recognition. All right, so we are going to go ahead and do document 4. Okay, say doc 4 equals to NLP. All right, we say I was, okay, let's say my name is Okonomics George. I was born in 1991. I wasn't born in 1991 though. I'm from Nigeria. All right, so let's go ahead and run this piece of code. All right, now let's go ahead and look at our named entity recognition. Say for token, okay, in doc 4, all right, doc 4, print token dot text Alright, so also token dot, we're looking at named entity, right? So named entity for token in doc4. This is our doc4, this is our doc3. All right, we state in doc4 print token.text is going to return this text to us, and we're going to say token dot label. All right, are you sure? Let's run now. spaCy tokens dot token dot tokenology has nothing with label. Token dot token dot, okay, for token in text, token. All right, so style equals to, let's say, tip. All right, so let's go ahead and run this. All right, so this has to go out and run this. Print. Alright, so let's just go ahead and do something. This is entity. Okay, so sorry, I'm trying to named entity, named entity, named entity. So you can also refer this to ChatGPT. That is why we have ChatGPT here to help us with some things. Alright, key component especially doc.end, extract name entities and document, end.text, text, the entity, enter label. Alright, okay, alright, so alright, better. Alright, so let's go ahead and run this for token in for end. Let's use for end in doc4 dot end. All right, print end dot text and end dot label underscore. Let's go ahead and run. Okay, right, so I'm going to do this as well. All right, please do well to, you can use what do we call, you can as well use ChatGPT if you have any, or Google. That is how we learned every day, and I forgot the syntax for this, so you can as well go ahead and use that. All right, so let's go ahead and print. All right, so now Okonamal Judge, the entity, named entity is what? Is person. This is telling me that this person, this name, what you are seeing here is person, is someone, is a person. Now 1991 is recognized that it's a date, and Nigeria is saying it's a geopolitical entity. It means it's a place. So this is the beauty of named entity recognition. So you say for end in document 4, this text, all right, print end.text, which is this text, and also this is giving us a space, this space you are seeing, and this is giving us this arrow that points to the nth label, and the n label is a person. So this is how you can build a model that recognizes what named entity. All right, so like I said, you can use you can go to spaCy documentation, you can see all those codes. You can as well use ChatGPT, or you can use Google to make references where you are missing it out. So don't be ashamed to make errors, don't be ashamed to build something and fail. There are tons of documentation or reference to what you are doing, so don't be ashamed. Like you see me, I referred back to ChatGPT. That was how I had to come back to understand, to remember that it is not document or label but token label but end and end dot label. So this is how we can get our named entity. So the last thing before I'm going to give you a bonus, since you have watched this tutorial till this moment, till this hour, till this time, to this level, I'll give you a bonus. All right, so the last thing before the bonus we are going to look at is dependency spacer. All right, so let's go ahead and say dependency spacer. Okay, right, so let's go ahead to our course outline. All right, and look at what dependency spacer stands for. You say dependency spacer is in spaCy analyzes the grammatical structure of a sentence by establishing relationship between words called dependencies. Each word is assigned a syntactic word rule, and the spacer identifies the head word that governs each dependency. So it's kind of a very big grammar, right? But when we go to the code, you understand what it means better. All right, so for us to have to work on this, we are going to first of all import a library. You say from spaCy import displacy. All right, what am I doing? It's a code, right? Okay. From spaCy import displacy. Okay, I was using it as a markup. All right, so let's go ahead from spaCy import displacy. All right, so we have been able to successfully imported our displacy for us to go ahead and do this analysis. Right, so what we are going to do now, we are still going to use this word. All right, this. So let's just copy this. All right, we're going to change it to doc5 rather, and we're going to go ahead and run it. Okay, so now let's go ahead and say for token in doc5. All right, so I hope I get this right. In doc5 we are going to print token.text, and we are going to look at the style equals towards to deep. All right, so let's go ahead and run this and see if it works. No, keyword argument for print. Let's see. All right, for text, token the text. All right, so All right, so we want to see how we can get this space, this our okay, so print token text, token label. All right, we're looking at spaCy. All right, so I can go ahead and do and tap shift tap. All right, let's go ahead and do something very quick. It's a print for token in doc5. All right, so we are using spaCy here. Okay, sorry. Sorry. Since you are using spaCy, you can say spaCy dot render. All right, what are we rendering? We are rendering document token dot text, and as well as token dot all right, so it says style equals to what's wrong with you? Let's use deep and let's run. The spaCy can only visualize doc or span. All right, for let's see, token dot doc5. Let's run. Okay. spaCy dot render. What we are rendering now is going to be token dot text comma all right, let me refer back to my Jupyter notebook. Okay, so print token dot text NLP documents for token in doc, print token. This is for the principal. Okay, token dot deep. Okay, for token in doc, print token dot text, token dot deep. Okay, so let's go ahead and do that. Let's go ahead and do that. Let's say for token in doc5. All right, so let's print in token dot text and token dot depth. This okay. All right, so it's giving us my as push, name as this, is as Okunamat as a compound, George as attributes, punctuation. Okay, so this is basically what. So there's a part I'm looking at how we can visualize this. To visualize this. So maybe in our next tutorial I will show you how to visualize this. So that is that for today. All right, so in our subsequent video I'm going to show you how to visualize this. All right, so there's what I just forgot we needed to use the spaCy, spaCy. Okay, let me just go ahead and see, try one more time. All right, so I can say spaCy dot render. Okay, now okay, document iterable doc spam. Okay, all right, so can iterate document. I say doc 5. Okay, and I can do what else? You can also look at this. Don't be ashamed of failing. Don't be ashamed. Okay, now we say style equals to, right, date. Let's go ahead. Okay, all right, so we are able to get this, what I was trying to get. All right, so basically what we have here is the same thing we have here, but here, okay, we can go ahead and say here to visualize visualize our dependency. All right, so now this is to visualize. If you look at here, all right, everything is contained here. You can go ahead and save this. All right, now the same thing, we have mine as a pronoun, all right, and it's a post. Now here name is a noun. So what this does is the same thing we have as here. Let me go ahead and do something like this so that you understand better. All right, so all right, stay with me. Stay with me. I'll go ahead and put this. I run this again. What? Okay, I have removed T. Token. It's supposed to be small T. Alright, let's run it again. Alright, so mine. This is what we are having here as the pacer, okay, dependency pacer. Alright. He name and compound, judge, attributes, punctuation, and all this. You can go ahead and look at the meaning of what this stands for. Now, but if you want to visualize our dependency, this is how you see spaCy is used to visualize. All right, and you say render doc. This is what we are visualizing. We can go ahead and visualize doc 4. Okay. Let's say doc 4. Let's look for something simple and also visualize. Doc 4 is still very large. Alright, let's go ahead and look at the first document we had. Or we can go ahead and do something. We can go ahead and do our own. Alright, we can go ahead and say doc 6. Alright. NLP, I say I love you. Alright, so we change it to doc 6, something simple, and run it. Alright, so as you can see, this is all what we have. This is it. So I is a pronoun, love is a verb, you is a pronoun, and these are you can go ahead and refer what this means. Okay, but this is basically how to visualize your dependency pacer, and this is how you can get it. So I hope you found the use. So the bonus I was looking at, all right, to give you a bonus, you can as well convert your sentence into words. All right. For example, let me give you a text or a document. Let me just do something quick. All right, say, let's say sent equals to NLP. I want to do something as I love Jesus, comma, he loves me too, and you go ahead and runs. Now you can you can remove sentences from your codes. All right, so you can go ahead and get different. Maybe you have a document and you want to break it down into sentences. All right, so there's what we need to do into sentence. All right, so I had it somewhere here. Okay, I had it. Just a minute. All right, let's go ahead and try something. We say for sent in sent. All right, you're going to print what we have as sent dot text. All right, and sent dot okay, let's just print send dot text and let's go ahead and run it. All right, but there's a better way to do this. He's giving us I love Jesus many times. Okay, we're not supposed to be like this. You can say send dot. Let's go ahead and check our. Now you can come here and it's going to give you everything you need to do this. All right, so when you leave it as none, it gives you as empty string. File supported, none, for literature, false, none, to string or true, separate. Alright, so you say for sent in sent. Right. Or we can say print, for token in sent, print token dot text. Let's go ahead and run this. Okay. All right. Now, this is what we have here. All right. Now we said we break down, like I said, it's a bonus how to convert different sentences. All right. So what I did here was that I gave a variable. I love Jesus, he loves me too. I want to break it down. Now, sentences are anything it says when NLP spaCy says a full stop, it automatically bring it as another sentence. All right. So this is how you can get sentences from different words. So, but there is a way we would have done this. It would have given us in a line. Okay, not just kind of like this. I'm trying to remember. I have a whole lot on my head. I'm trying to remember this. Please bear with me. It's good to make errors, try and errors. That is the beauty of learning, teaching and learning. All right. So we want to do this to become okay. Let's try another method. Let's just say token docent. No, it's not gonna give you for token in send. Print token dot text and token dot send. Let's see what happens. Okay, but later repeating this. Token dot send. No. let's say token dot send. Alright, so in our next tutorial I'll fine tune this and give us. So I hope you find value in this tutorial, in this course. Please do well to subscribe, click that like buttons, and share this video to your loved ones. And please do well to practice this code as well. If you find any useful concept you want me to know, please, you can also put on the comment section and let me know what you think about it. So without further ado, I'll end here. Don't forget, my name is George. I am a data scientist and I teach machine learning and also data science generally. So do well to subscribe if you are not subscribed, and see you in our next tutorial. Thank you and God bless you. Alright, so let's go ahead and sorry about the delay. Let's go ahead and complete the bonus I promised giving to you by showing you how to convert your text sentences in NLP using spaCy. Alright, so let's go ahead and click run all so that you don't have any issues while we are trying to. Alright, so before our code the running process complete, I want you to understand that it is very possible for you to build a model that splits text or document into sentences. So now, for example, you are writing a project and you want to have everything to be on its own, like sentences, right? It's very possible for you to do that with NLP or with spaCy. Alright, so let's go ahead. We already gotten our variable sent, which we want to split into two sentences as we have there. You can say for send, let's use S, in send. Alright, let's use a document here, please. Let's go ahead and say doc 7, and let's run this again. Alright, for send in doc 7 dot sent. Alright, so we are going to print. Alright, please follow me. Send dot text. Let's go ahead and run this. Alright, so as you can see, we have now two sentences. If we look at our doc 7, I love Jesus, full stop. I love Jesus, full stop. Now he loves me too. Now he loves me too. So this is how you can be able to do what? To split your data or to split your document, your text into sentences. I hope this video was good. I hope you enjoyed this course. Please do well to give a thumbs up and subscribe, and also share this video. If you are taking this as a course, please do well to put everything you have learned today into practice. Thank you and see you in our next tutorial.